Okay, you can see the screen?
Yeah.
Right. So what's your see, first thing is you have to draw the diagram. You don't skip the steps.
Okay.
Okay. And they are given the steps for a reason, so that
Okay.
you get used to the right way of solving the problem. So when you draw so you understood the diagram which I have drawn here.
Um,
See this dot,
no.
you can see my pointer, right?
Yeah, I can.
So this dotted thing is a water. Okay.
Okay.
So this is a river surface.
Okay.
Okay. And here there is a bridge at a height.
Okay.
Okay. So bridge, the rigid surface always represented with a short dash. Okay. And since the bridge is a solid surface, I'm representing like that. And that height is given as 321 meters. Height of the bridge above the water. Is that right? I can't hear
Yeah.
you. Yeah. So 321 meters. And the initial velocity is 5 meters per second. That is V naught. Okay. And the initial velocity, the direction is what?
The initial velocity for
Direction.
vertical?
No, horizontal. It's being kicked from a height, right? So if you kick it vertically, it will get into
Yeah.
the bridge. It cannot penetrate the bridge, no?
Yeah.
Bridge is concrete surface.
No.
Okay, so you can kick it horizontally.
Okay.
Okay, so the initial horizontal velocity is 5 meters per second.
Yeah, yeah, I got that.
That's what I said also, right? You kick a rock
Yeah, I said it was,
you kick
yeah,
a
I said it
rock,
was flat.
you kick a rock horizontally off the bridge. So the initial velocity is
Yeah.
horizontal and it's 5 meters per second. So this is the data that's been given in the problem.
Yes.
Okay, the first step is to draw the diagram and include
Okay.
all the numbers, information given in the problem into this diagram.
Okay.
Okay, so that you don't have to read the question again.
Okay.
Okay, so and once you focus on this diagram, understanding the problem will be much easier
Okay.
rather than
Just
reading the question again and again and try to understand what is going on.
okay.
Okay, and x-axis I am choosing like this, y-axis I am
Mm-hmm.
choosing like this. So origin is at the river surface.
Mm-hmm.
And the upward direction is positive for y and the right direction is positive for x.
Yes.
Okay, so this thing I have y colon means I'm analyzing the y motion.
Okay.
Okay, so in the y motion the initial velocity is how much?
0.
Because
Wait, why is it 0?
I'm considering the y motion.
Oh,
See,
yeah, yeah,
you can, you
0.
can you can consider y motion and x motion separately, and you have to consider, otherwise it's difficult to analyze.
I have a question. So for your Y motion is it always 0?
Not always. In this case, it's zero because it's being kicked horizontally, right?
Yeah, but in all of these problems, it's always being kicked horizontally.
No, no,
That's
that you can see
oh,
individually. Okay, but
okay,
just stick to this problem.
okay.
In this particular problem, the initial velocity is horizontal. So in the y motion, initial velocity is zero,
Yeah.
and the displacement in the y motion is half at square plus v naught t plus y naught.
Okay, why did you use that equation?
See, in the equation they are given x equal to half at square plus v naught t plus x naught, right? This is true for any displacement. The
Okay.
displacement can be along x, it can be along y, it can be at some other line along this direction. Any direction, the displacement is given as half into acceleration in the direction into time square plus velocity, initial velocity in the direction into time plus the initial displacement in that direction. Okay,
Okay.
so this is applicable for any direction.
Any direction?
Yeah,
Oh, so it can also be used for Y.
yes,
You just replace everything with Y.
yes. So even this v equal to 8, okay, here the direction is not mentioned. This is applicable for x motion and y motion.
Yes.
And this equation is written for x, right? You can also replace this by y equal to vt plus y naught.
Okay.
Okay, but since it's repeating, you don't have to repeat, right? You just have to understand it's a variable. So whatever is applicable for x is applicable for y also.
Okay. But your V equations, like V equals AT plus V sub 0 and V squared equals
Yeah, it's
2AT.
actually the
That's
understanding. The understanding is the V is Y component V. V naught is Y component V naught.
But can it be used for X?
No, see, if you want to be very specific, you have to write this V as V suffix X.
Oh, okay. V, okay, yeah.
But you understand, right, what is going on?
Yes.
Okay, so once you have that understanding, you don't have to make the symbol more and more complicated. But initially, if you are getting confused, you just have to put V suffix X or V suffix Y. Okay, for X motion and Y motion. Similarly, A will have A suffix X and A suffix Y.
Okay.
Suffix
So
you understand, right?
Yeah.
A sub X.
That's for X.
Like V naught is V suffix V naught, right?
Yeah.
Or V sub V naught, whatever you call it.
Yeah, your initial.
Yeah. So similarly, you can consider V as Vx and Vy. So Vx equal to Axt plus V naught X. V naught X in the sense V naught, the X component of it.
Okay.
So we have another equation Vy equal to Ayt plus V naught Y.
Okay.
T has got not any component. T is a scalar.
Yeah.
T is same for both.
Okay.
Okay. So the Y component displacement equation is this one.
So at school, we're supposed to like label what we have and what we don't have. So we make an X and Y table.
Not necessary. Okay, we'll come to that later. Just follow what I'm doing. So V naught is 0. So Y is this one. And the thing when it reaches the ground, see, this thing will go like this, right? Are you following my pointer?
Yeah, I am.
So finally it will hit the river. Okay, or wherever is the ground. Okay, so when it reaches the ground or the river, what is the value of Y?
When it reaches like 0?
Yeah, because origin of Y is at the river level or the ground level. Okay, so finally the Y is 0. So if you put that value of Y, that T will correspond to the time it takes to go from here to here.
Yeah.
Okay, is that there the time of flight?
Yeah, that's what we don't know.
Yeah, that we can calculate. And acceleration is minus G. Why is it minus?
Isn't acceleration 0 for the isn't it negative 9.8 meters per second?
That's what I've written. G is whatever value you can put, 9.8 or 10.
Oh, okay, yeah.
But you can put the value in the end, just put the symbol first. So acceleration is minus G, is that correct?
Yeah, it's always negative because it's falling.
That's what you should not do. It's not always negative. You're choosing the direction of Y as positive upwards. If you choose the direction of positive upwards, always, then the acceleration is minus G always. But here in this case, I've chosen positive Y as upwards and acceleration is downwards, right?
Yeah.
Because Earth is going to pull it down.
Yeah, it's falling.
Yeah. So since my positive Y is upwards, the acceleration is negative.
Okay.
Okay, you have to understand like that. It depends. It should be consistent with the choice of my axis.
Okay.
Okay. Since I've chosen upward as positive, acceleration is downward, so it's negative. Okay. And V naught is 0. So it is the second term is 0. And Y naught is how much?
Isn't that 0?
Initially it's here, no?
So Y sub 0 would be 0.
Origin of Y is here, no? At the river surface.
Yeah.
So initial Y is Y naught, that is equal to this 321.
Well, so Y naught would be 321 because it's starting at 321.
Yeah, because I'm choosing my origin as on the river surface.
Okay.
Okay, since I'm choosing my origin at the river surface, the initial Y naught is 321 and it is plus 321.
Okay.
Why is it plus 321?
Because it's rising 320 meters above, so it's positive.
Yeah, it's in the positive y-axis.
Okay.
Okay, so in this equation, everything is known, right, except for t.
Yes.
So this term I can take it there. So and g by 2, if I take g as 10, then it will be 5. So 321 by 5. So it will be 5 times 6. So 64 plus 1 by 5. So it's approximately 8. So if you put g equal to 9.8, it will be still closer to 8. Okay.
Okay.
So if you don't like G as 10, you put G as 9.8 and get the value. This you know how to calculate, right? T square.
Yeah. So time is 65.5. So why did you divide it by 1/5?
See, this is just for calculating without the calculator. This is 30, right? So
Yeah.
5 6 are 30 and remainder is 2. So 21. So 5 4s are 20. So remainder is 1, right?
Yeah.
So 1 divided by 5. It'll go
Okay,
6.
so I just typed in 321 divided by 4.9 because that's exact, and I got 65.5.
And you have
So
to
when
take the square root, right? This is T square.
oh, that was my mistake then.
No, that you made the mistake when writing the equation, first equation.
Yeah, but my time was right. Like even when I redid it, my time was right.
T square was right.
Yeah. So the time is 8.9. I forgot to take the square root. Okay. And then with my time, I can solve for v. That's what I want. I want my velocity.
Don't skip the steps. Next is you're analyzing the x motion.
Well,
Okay.
I thought we could go out of order depending on what's easiest to find,
No,
right? No? Okay.
it's fine.
Then
No,
I'll
no,
just go
I'm not
on.
saying anything, but just follow what I've written here. No,
Okay, I will.
both are same. So next I'm
Okay.
analyzing the x motion. So x equal to vt plus x naught. Is that true?
Yeah, that's the equation.
Why is this true?
Why is this true? Because x is your horizontal range, like delta x,
No, this equation is valid for acceleration equal to
velocity over time.
acceleration is 0 here. See, this equation is valid for
Oh,
constant
yeah.
when uniform velocity, right? Constant
Yeah.
velocity. So the acceleration should be 0. So
Yeah, yeah. Isn't
so
it because in the horizontal motion, it's always 0?
why is the acceleration in the horizontal direction 0?
Well, that's what our teacher told us. It's
No,
because like eventually when it falls, it'll pick up acceleration, but
no,
in the horizontal movement, it's always
but
0.
you have to understand what the teacher is telling. See, the earth is going to pull it downward, vertically downwards, right?
Yeah.
It's not going to push in the x direction. It's going to only pull it down.
Mm-hmm.
Okay, so it will not give any force in the horizontal direction.
Okay.
So only when there is a force, there will be acceleration.
Okay.
Okay, so the force is only vertically downwards, which is along y. So the acceleration will be only along y direction.
Oh, there's no force for horizontal.
Yeah, earth is going to
Okay.
only pull it vertically downwards, right?
Mm-hmm.
So there is no force by the earth which will push it in the horizontal direction. So that is why in the x direction, acceleration is 0.
So
Okay,
isn't x sub 0, 0?
no, not necessarily. That is a independent. Here in this case, since the origin of x-axis is here, so
Mm-hmm.
initially x naught is 0.
Yeah.
In this
Wait. Can you explain why it's 0 again?
x naught in this particular case is 0, not always.
Wait, can you explain why?
See, the origin is here, right? And
Oh, that's it.
initial position is here. To get the
Yeah.
value of x, I have to drop a perpendicular from here. So what is the value of x at this point? 0, right?
Yeah, 0.
And y is 321. Why not?
Yes.
So
Okay,
that
so
is
x equals
so
0
that's your
plus.
y naught is 321 here, but x naught is
Okay.
0, and v is 5 meters per second, and v is not going to change with time. Initially, v in the x direction is 5,
Mm-hmm.
and it will remain 5 because it's not going to change.
So v sub 0 is going to be 5 and v is going to be 5.
In the
Initial and
horizontal,
final velocities are going to be the same.
direction, in the x
Yeah, yeah.
direction.
That's what I
Yeah,
meant. Okay. So 5 times like 8.09.
yeah, whatever is the time you get.
That's like 40.4.
Yeah.
Okay.
So now I'm again go to the y motion.
So when they give you like v equals at plus v sub 0, is that mostly for your vertical
No,
direction?
it's for both.
Okay. But in this sense, because I want the speed, impact speed, that's for y, my vertical
Yeah,
velocity.
Horizontal impact speed is known.
Yeah,
What is it?
5 meters per second.
Because it's not going to change.
Yeah.
Okay, so
it's
only I have to calculate the vertical impact speed. So y impact speed, this
v sub
equation
0 is 0. Your initial velocity is 0.
in the y direction.
Yes.
Okay, so from this you get a as minus g, and acceleration in the y direction is g.
Yeah. So that would be negative 9.8 times 8.
Yeah. So 79 point something.
Um, it's negative 79.3
Yeah.
meters per second. Would my unit for x, the range, just be at meters?
Yeah.
Okay.
So impact speed will be square, so speed is square root of x, vx square plus vy square.
Yeah, I just forgot to take the square root
No,
of that.
so the impact speed will be 5 square plus 80 square or 79 point something square,
Mm-hmm.
and then square root of it.
Okay.
So the velocity vector, the x component is vx, y component is vy. So if you want to get the magnitude of the vector, it's square root of vx square plus vy square. That you know, right?
Yeah.
So vy is 80 or something, or 79 point something, and vx is 5. So
Mhm.
speed will be square root of 5 square plus 79 point something square.
Okay.
So it should be slightly more than, it should be around 81 or something, or 79, 80, something like that.
Yeah.
Okay, that will be the
Like
impact speed.
9.3. And then like for your x and t graph,
Yeah, so we have this equation, right? X equal to vt plus x naught equal to, okay, and x naught is 0.
yeah.
And so it is 5 into t.
Mm-hmm.
So this is the x at any t. This is the x at final time. So that's why I put the final time of 8 seconds here. But I want this x for any time because we are plotting a graph. So
Does
that's
it
why
say?
you put t as a variable, not a value. See, when you're plotting, you need variables, right?
No, I know. Why are you like doing this step though?
See, equation of line is what? Y equal to mx plus c, right?
Yeah.
I need to connect two variables, y and x.
Mm-hmm.
So similarly here, the y-axis is the displacement x, and the x-axis is t. So I
Mm-hmm.
need an equation relating both x and t. This is the equation. In this, I put x naught equal to 0, and x naught is 0, and t is the time, variable time, and
Mm-hmm.
velocity is constant speed, constant velocity in the horizontal direction. That is 5.
Mm-hmm.
So I have this equation x equal to 5 into t. So this is my equation.
Okay.
So at t equal to 0, x equal to 0, so it will pass through origin, and it's a straight line, and this is slope of the straight line is 5.
Okay.
Slope of the straight line can draw like this.
Yeah. For that graph, why is your line going up? Because it's rising.
Yeah, as time increases, x will increase, right?
Okay, and then for your y, your v versus t graph.
So here we see all the graphs is for x direction. Is given,
Oh,
right?
it's all in the x direction, and your velocity is constant the whole time.
Yeah.
And then if it's rising, won't it be slowing down at the end?
No, that is the total velocity.
No, I'm talking about your acceleration.
Acceleration in the vertical direction. See, there is no acceleration in the horizontal
It would just be
direction.
0 if we were to do it for x.
You understood the question, right? For the rock
Yeah.
in the x direction. So only you have to bother about the x motion.
Mm-hmm.
So forget the y motion. You're handling both the motions separately. So
Mm-hmm.
the graphs is only for the x motion.
Right. So wouldn't your acceleration just be 0 for your
Yeah.
x direction?
Yeah, that's what I drawn here.
Okay, sorry, I got confused.
So now everything is clear.
Yeah, I'm fine. I think I'm gonna do the second problem on my own.
Yeah.
And I think you gave me the solution, so I'll check it afterwards. And if I have questions,
Yeah.
I'll
So
let
do one thing. You just attempt the question on your own and follow the steps. When they say draw a diagram, they say it with a reason. Okay.
Okay.
So follow the steps they are saying.
Okay.
Okay. So first step of a problem is you have to draw the diagram and include
Mm-hmm.
all the data in the question into the diagram so that you don't have to read the question again.
Okay.
You can read the question if it's absolutely necessary, but to avoid that, if you put everything in the diagram, it will be clear how to proceed.
Okay. And
Okay.
then
Yeah.
okay. And then yesterday she gave us symmetrical launches,
Yeah.
but I looked at it and I had no idea and there was no video or anything to go
Okay.
along with it.
Okay.
I might have forgotten to email this to you, so I'll do it now.
Yeah. So what time is your class start? It start in 15 minutes, right?
No, it starts at 10:30. It's 9:15 here.
Okay. Oh, it's a lot
Yeah,
of
I have
time.
late arrival today, so I get to school starts at 10:30.
Okay. Right now it's 9:15, is it?
Yeah.
7:45, 8:45, 9:15. Okay, fine. So time is there. Right. So, and what time you sleep in the night for you?
Like on a school day, usually I go to bed like kind of late, anywhere from 11 to 12, but sometimes 1. But today, since we had late arrival, I could sleep in, so I just went to bed at like 1. But then 3 days a week, I have to get up an hour early because I have a class through
Mhm.
school.
Okay.
So,
Okay. So the thing is, you have to give me stuff and then you have to give me 1 day time at least to have
okay.
the discussion because it will make it easier for me. See, all these things I've already done. After that,
Hmm.
it's easier to discuss. If I'm discussing
Yeah.
with you, then I myself will get confused.
Okay.
It will take a longer time. So you have to give me at least 1 day time.
Okay.
Okay. So I'll try to catch you tomorrow morning my time, night your time. If it
Okay.
is
Yeah, that's fine.
if you are awake and I'm available.
Hmm.
So
Do you know
uh,
what time?
yeah, I'll just check. I'll just send you message, WhatsApp message, and then we'll
Okay.
decide.
Okay.
Okay. So if there's anything, you just message me.
Okay.
Okay. Uh, do one thing. This problem number one, you just hide the solution and try to solve it again, so that just to make sure that the things are entered in your memory
Okay, I'll do it.
without skipping the steps. Okay. Don't skip the steps. Otherwise, you'll make mistakes. And once you do these things, you go to the second problem.
Okay.
Okay. Fine. Shall
Okay,
we
thank you.
close?
Bye. Wait, what'd you say?
Should we close now?
Yeah, I'm fine.
If there's anything, you message me. Okay, so
Okay.
that revision package you can try, right? So the
The
revision
review
package,
packet? Yeah, I started that. I started it. I wanted to do that over the weekend, so I already have some of the problems done.
yeah. So anything you don't skip the steps.
No, I won't.
Okay, the first step, the where you draw the figure and put all the information, that's called paraphrasing. Okay,
Sorry, can you repeat?
it's called paraphrasing.
Okay.
What is paraphrasing? It's translating the problem into your
Mm-hmm.
own language.
Mm-hmm.
Okay, so that it becomes easier for you to solve.
Okay.
So first thing is draw a diagram, or if the diagram is already there, try to put in as first information, all the information in the problem, you put it in that diagram in terms of symbols and whatever. Okay,
Mm-hmm.
so that you don't have to read the question again, and also the understanding the problem will be easier.
Okay.
Concentration will be on finding the solution, not on try to understand the problem.
Okay.
Once the figure is there, it's easier for you to understand.
Okay.
Okay, message me if there is something.
Thank you so much. Bye.
Yeah, bye.